Thank you for your kind introduction. My name is René Liebers, and I'm working for 3D Micromac, and I want to show you how we could support the micro-LED production with our laser-based tools and processes. But first of all, for those who don't know us, as 3D Micromac, what are we doing in general? We are a leading specialist in laser micromachining, and we are typically developing processes. And finally, the goal is to bring processes into production, whether for R&D or finally for mass production. We typically support our customers with a strong process know-how, and we have 20 years of experience in laser micromachining. Up to now, we have more than 600 machines installed worldwide. It's not just display, it's also semiconductor industry as well as glass and display. We also produce machines for microdiagnostics applications and photovoltaics, and also for flexible devices, roll-to-roll systems. Competency-wise, this is widespread. Our know-how comes from laser structuring at the one side, selective removal of thin films, for instance. Then we have laser thinning applications, special application for sample preparation. Then we have annealing processes for semiconductor, like omni contact formation or magnetic sensor formation. Then we can do precise laser drilling, for instance, for nozzles. And then we have singulation processes, dicing for semiconductor or display applications, or for photovoltaics. And last but not least, that's why we are here, for laser lift-off and transfer processes for displays or sensors. When you have a look on a mobile device or a device with a display, you have a lot of laser processes which are commonly used within the last decade, let's say. These are mature processes, but for micro-LED especially, you already heard that there are specific requirements. And when you have a view on a typical production route for microdisplays, as an example, we can provide machining solution and processes for laser lift-off, for the transfer process step, as well as for the bonding, and finally the repair process of defective dies. First of all, the laser lift-off. You already heard about this today, this morning. This is the debonding process step directly up after the epitaxial growth of the devices. And afterwards, a debonding process is required to remove the active layer from the sapphire wafer and to release it, finally. For this process step, we have two machines or two concepts in place. On the left-hand side, you see a machine called MicroCT. This is equipped with an on-the-fly approach. This typically uses an excimer laser sources in a deep UV, where we apply a rectangular laser beam to cover the whole substrate. This is the, let's say, low-end approach regarding throughput. The more commonly used tool is here the Micromac. You can see on the right-hand side. This is the approach with a continuous line beam, which covers the whole substrate, whether wafer size, for instance, 8-inch, or even panel substrates with a line width of up to 750 millimeter in length. And crucial for this process is the homogeneity of the laser beam, finally. And throughputs up to 60 wafer per hour are possible with this system. Here I want to highlight a specific topic. When you talk about laser lift-off, you are using the sapphire wafer, and it needs to be grinded before the lift-off process. But if you want to skip this expensive process, then it is possible to skip the grinding and to apply a liquid on the surface. Then you cure the liquid, and then finally you equal the surface. This finally results in reducing the required laser fluence or laser energy. And finally, it is possible